Hi and Assalamualaikum. My name is Siti Nurul Aisyah binti Abdul Aziz and my matrix number is 2020-841628. So in this video, I'll be conducting 5 experiments, which is moisture content, particle density test, particle size distribution, sieve analysis, field density, and lastly permeability. Now I'm going to start the first experiment, which is moisture content. So the objective of this experiment is to determine the moisture content of the soil. The apparatus needed for this test is scale as balance, box as dry oven, soil sample, plastic bowl with lid, spoon as spatula, and cleaning brush. The mass of an empty, clean and dry plastic bowl with its lid is determined and recorded. The moist soil is placed into the plastic bowl and the lid is secured. Weigh the plastic bowl and the mass is recorded. The lid is removed. The plastic bowl is placed into the box that acts as dry oven at 105 degrees Celsius for 24 hours and it is left for overnight. Remove the plastic bowl from the oven. Carefully place the lid on the plastic bowl. It is allowed to cool at room temperature. Weigh the plastic bowl and the mass is recorded. Empty the plastic bowl and clean it with its lid using a cleaning brush. That's all for this test. This is the data obtained for this test. The second test is particle density test. The objective of this test is to determine the specific gravity of the soil. The apparatus needed for this test is box as vacuum, basin as water bath, water as distilled water, soil sample, plastic bowl as density bottle, plastic bowl lid as stopper, spoon as spatula, and also scale as balance. Clean and dry the plastic bowl and stopper properly. Weigh the plastic bowl with stopper and record the mass as M1. Take about 10 to 20 grams of dried soil sample. Pour it carefully into the plastic bowl. Weigh the plastic bowl with soil and stopper. Record the mass as M2. Pour about 10 ml water in the plastic bowl to soak the soil. Leave it for a period of 2 to 10 hours. Pour some more water to make the plastic bowl half full. Remove the entrapped air by applying partial vacuum. Next, pour some more water into the plastic bowl and fill it completely without any entrapped bubble and put the stopper on. Keep the plastic bowl on the basin that acts as water bath for 1 hour. Take out the plastic bowl from water bath and wipe it clean and dry from outside. Weigh the plastic bowl filled with water and soil sample with stopper. Record the mass as M3. Empty the plastic bowl and clean it properly. Fill the plastic bowl entirely with water. Make sure there are no entrapped air bubbles or otherwise the partial vacuum has to be used. Weigh and record the mass as M4. Again, empty the plastic bowl and dry it up properly. This is the table data obtained for this test. The third test is particle size distribution, sieve analysis. The objective of this test is to determine the percentage of different grain sizes contained within a soil. The apparatus needed for this test is lid, soil sample, cleaning brush, scale as balance, bowl as pen, tiffin carrier as set of sieve, and a box as mechanical sieve shaker. Prepare the soil sample and record the weight of the dry soil sample. Clean each of the sieve to be used and record the weight. Arrange the sieve in order with larger opening of sieve size at the top to the smallest at the bottom. Place the pen below the smallest sieve size. Carefully pour the soil sample into the top sieve and place the lid over it. Place the sieve stack in the box that acts as mechanical sieve shaker and shake for 15 minutes. Remove the stack from the shaker. This is the soil retained in each of the sieve. Carefully weigh and record the weight of each sieve with its retained soil. This is the table data obtained for this test. The fourth test is field density test. The objective of this test is to determine the dry density of the soil. The apparatus needed for this test is bowl as container, Ottawa sand, soil sample, hammer, plastic cup as a pouring cylinder, pepper that has hole at the center, cleaning brush, painting brush as pack, spoon as scraper. Level the soil sample using a scraper. The pepper that has hole at the center that act as metal tray is placed at the prepared surface. Secure it with the painting brush that act as pack to avoid the pepper from moving when doing experiment. And then excavate the soil below the hole of the metal tray and collect the soil on the metal tray. Make sure the soil does not escape from the metal tray before removing the packs. Carefully lift the metal tray on top of the container and put the soil into the container. Put the metal tray back on the ground and the plastic cup that acts as pouring cylinder is placed centrally over the excavated hole and pour the Ottawa sand into the pouring cylinder. Remove the pouring cylinder, scrape and level the excess Ottawa sand on the metal tray. Lift the metal tray and put the excess Ottawa sand into the container. The collected soil will be tested in lab. This is the table data obtained for this test. Lastly is the permeability test, which is constant head test. The objective of the experiment is to determine the coefficient of permeability of coarse-grained soil. The apparatus needed for this test is scissors as vernier caliper, ruler to measure the head difference, and stopwatch. Plastic cup as measuring cylinder, water bottle as permeometer, straw as standpipes, rope as manometer tube, and plastic Tupperware as water tank. For this test, water tank on the top is used to keep the water level constant to the whole test. These three straws act as the standpipe that are attached to the wall. This water bottle acts as a permeometer that contains various types of soil. The plastic cup acts as a measuring cylinder. There is also a Helsam valve at this area that can open and close manually. This is the first valve, second valve, and the third valve. The last valve located at the base plate of the permeometer is connected to the water tank by this tube. There is also a rubber tube that is connected from permeometer to measuring cylinder. Firstly, remove the top plate of the permeometer to measure the diameter. Measure the inner diameter by using scissors that act as vernier caliper. And then don't forget to measure the diameter of the standpipe. Open the valve at the water tank that connect to the base plate of the permeometer. Open this valve, and this valve. And then open these three valves to allow the water to flow to the standpipe. And don't forget to measure the height difference between the top standpipe to middle and middle to the bottom. Prepare the empty measuring cylinder to run the test. Open the valve that connects the permeometer to measuring cylinder. By using the stopwatch, take the time for 500 ml, 700 ml, and 1000 ml and record the data. This is the table data obtained for this test. This is the discussion for every test. Lastly, the conclusion for every test.